Hello everyone, I've made a lot of changes since I last showed you an update video. A lot of these changes are under the hood, but they add in the groundwork for later features. The first feature that I've really worked on has been the rules. All game modes should theoretically be supported by this system, provided that the rules are changed. So, apart from the game rules, everything else would be very, very generic. The actors as well as the only other specific part of the system. This means that you could switch out the game rules and have a completely different game only at the cost of a single class. That's the theory anyway. So in order to do this, I had to make some changes to the connection classes. Beforehand I had about 500 lines of code, whereas now, after all of my changes, I have 935. And a lot of these comprise the connection classes. There is a base connection which simply handles the sending and receiving of data, and this is extended by the RPC connection, and in that in turn by the client and server connections, which add on top of that the protocols for connecting, disconnecting, and handling replication data. The reason that I haven't simply tied this all into the single connection class and moved connection with RPC is that, in theory, you might want to add non-replicating functionality, or simply being able to send messages aside of replication, and for that reason I've added in this separate base class. I might change this later on, but it shouldn't really do much difference in terms of the code base. I had to make some changes. Beforehand you explicitly declared a server socket or a client socket, and those in turn, all they did was explicitly call a server or a client connection. The difference is now that the connection class has a new method which will return the correct type of connection class depending on the current net mode. It's important to realise that because of this, you must declare your net mode before you instantiate any connections. This is simply to make things a little bit faster in the system, otherwise I'd have to perform some trickery inside of the connection class. In fact, that's not the case. I'd still have to determine the connection before you instantiate it. So basically it's best to declare the net mode as high up in your stack as you can. Apart from that, the other changes have been for RPCs. In fact, I should quickly cover this first. There's the pre-init and post-init functions. These are custom send and receive functions which are called depending on the initialization status. This means you can separate out the setup logic from the running logic and remove a few explicit if statements. So these are the main changes here. A lot of the time it's about sending a reliable packet once and determining if it's been acknowledged or failed, and if it failed, we'll automatically resend it anyway. So that's actually made use of the reliable system quite nicely, and I'm really pleased about that. Apart from that, I also added a network error type for use in the game rules. This derives from the exception, but it also has a type register metaclass, and this type register metaclass is also used in the replicable base class. Fundamentally, all this does is any new class that derives from the network error or from the replicable registers itself on those base classes with its name to its class mapping. This means that when we send things over the network, we can recreate an instance from a string by sending its type name, and it keeps it safe, and it's sort of sandbox in the sense that as long as you can't really create an instance from a type that isn't stored in these base classes. The only real requirements are that anything you import, which is actors or exceptions, they all have to be defined on both the client and the server. But that's a fundamental given anyway. So in these game rules, the pre-initializer is called when a client connects, and if it turns out we have too many connections through the connection.instances, we can raise a player limit reached error. This is then suppressed and replicated to the client where it is raised, so the client will actually get the player limit reached exception, which I find quite nice. Otherwise, we can determine that if it is a client, we'll create a replicable. Simply creating this replicable will automatically register itself for updating, so you don't need to register it anywhere, which is quite useful. As well as this, there's the post-initialize, which is called after the connection has been created, and it's given a replicable on the connection. Here I've made use of an example of replication where I set the replicable name attribute to the name of the connection. The connection name is set when the client connects, so technically the replicable name is set to the client's name. The reason I've done this demonstration is you can see that it's replicated back to the client through the replication system and not through another fundamentally explicitly typed system. As well as this, there's the relevancy checks. These are used to cut down the logic. Supposing we had 64 connected clients and no NPCs, to replicate everything to everyone would be 64 to the power of 2. That's a lot of logic to process, so instead of doing that, we simply want to reduce the number of clients connected to a sensible number. That could be 64, but I think it'd be best to be 16 for now, and we can always cut that down even more if it turns out to be too high. As well as this, you only send to each connection what it needs, so there's no point sending it data about something it can't see, unless it's explicitly needed as part of the game mode, and there's no point sending something that it is invisible, nor to send something that it doesn't need any information it doesn't need. So for that reason we send the isRelevant. We use the isRelevant clause of the game rules. As well as this, I've added RPCs, and that's probably the biggest change. These net roles, as I've said, are switched depending on the context now. So if you're on a client, the local role will become the remote role and vice versa. As well as this, if it turns out that the remote role is an autonomous proxy, the server will quickly switch that out to a simulated proxy before it sends it, so that autonomous proxies only exist on the client who owns them. Anyway, back to the system. Currently, the only way to execute a function call on the client is to use a notifying variable. Let's say we created a variable called sound and made it a string. We can set it to notify and then put a condition in the onNotify function that when the sound variable is changed, we'll play a sound with that value. But that's something called broadcasting, and it applies to all clients. There may be times when we only want to send data to the client who's actually controlling the avatar on the server, and for that we use replication of functions. Likewise, only that client can send a replication function back to the server. So in order to do this, we simply run an RPC. Defining the RPC will, when it's called, if it's called on the client and it's sent to the client, it will simply execute it there and then. I might add support later for the local role suppression as the Unreal do. Likewise, if it's sent to the server, it'll actually suppress it on the client and execute it on the server. It doesn't support return values, and you have to statically type all the arguments as you do with the attributes anyway. This is to make things faster and simpler to use. So how do we do this? We define the RPC decorator. Any arguments we put in the function must be used to function annotation so we can define their types. This means we use static value and put the type of the value in the initializer. So in this case I have a message argument with a colon followed by static value of the type string. The reason I use static value and not just simply providing the string type is so that you can provide extra additional information like the precision of floats, which you can't do with a simple string value. Using the return value, we can set an arrow which basically looks like a target. That's why I've used a return value, and this simply says that this function must be executed where the net mode is equal to client, which is the client. Lastly, I've got a demonstration for you guys, I think. I'll quickly just check that this doesn't break on me. So, when I turn the server on, when I connect to it, it'll say Angus connected. And you'll see something that says Hey Server in the client window. That's because I was testing on the client earlier. If I go to Actors and set this targeting the server, this will now run the RPC on the server. So I'll turn the server on and then say Hey Server, and you'll see in the client console it says name equals Angus, and that's simply because I've sent the name to the server's applied it to the replicable robot instance, and it's sent it back to me. And that's all of the changes. I did make a shorter video, but I've realised that I say quite a lot when I'm tired, so I decided to re-record this. So thank you for listening, and it's good to be getting finally done with this. Thanks for watching.